students, in this video today we will continue our studies of lines and their graphs on the coordinate plane. Today though will be a little different. We're not going to be graphing linear equations. We will be graphing linear inequalities, okay? Not too difficult, pretty simple actually, but a little different. Your heading today is graphing linear inequalities, lesson 2.5, and be sure and include today's date, alright? Graphing linear inequalities, lesson 2.5, and be sure and include today's date, okay? Alright, moving on. Now, one of the first things you might think is, Mr. Earhart, we have already graphed linear inequalities. And if you thought that, you are correct. But let me show you the difference of what we've done in the past and what we're going to do today. In the past, we had something like this, and you do not need to write this down, just watch. I don't know, 7, bring the 3 over, make it a -3. 2x is less than or equal to 4, divide by 2, and you would get this. And then what did I have you do? I had you graph it. Here's 0, here's 4, close your point because there's a line here, x is less than 4, okay? And then we also graphed conjunctions where there'd be a number here like -5 and something like that. So yes, if you're thinking, wait a second, Mr. Earhart, we've graphed these already, you're right, but we graphed them, are you ready for this, on a what? Number line. The difference is today we're going to graph these on the coordinate plane, the x and y coordinate plane, okay? So that's the difference, do you understand? So I'll make sure I'm very clear on tests and quizzes as to how I want you to graph these, whether on a number line or the coordinate plane. So today we're going to graph linear inequalities on the coordinate plane. Now, having shown you this difference, let's jump right into this, okay? I'm going to go fast through the steps because I know you can pause the video and copy them before you continue on, okay? So here are the steps for graphing linear inequalities. There are just 2 of them. The first thing you do is you pretend that the inequality symbol is an equal sign, okay? And you graph the line using any of your 3 methods that you learned the other day. Remember your 3 methods, the table of value methods, the slope intercept method, and the double intercept method, okay? So the first thing you do is you pretend that the inequality symbol is an equal sign. So let's say you're given an equation or inequality like this. You pretend that is an equal sign, okay? Now you don't cross it off like that, but you pretend there's an equal sign there. And then you graph the line just like you've learned to do. Be sure to check to see if the line is dotted or solid. We'll talk about that later. And then step 2, decide where to shade. You have to shade on these, okay? For example, you might have a line that's slanted like this. You're either going to shade above the line or you're going to shade below the line, okay? So you have to decide where to shade. If it's a vertical or horizontal line, then it's easy. I will show that to you. If it's a slanted line, it's going to take a little more work. You will have to test a point and see where to shade, okay? So, not too difficult. Let's get started. So I'm going to jump on like this. So if you're not done copying these steps down, pause the video, finish copying these, and then we're going to move on, okay? Alright, here we go. And actually, I forgot that the steps are still up here too, so either way, let's continue on. Now, let's graph this inequality. And you're like, Mr. Earhart, we've done this already. Yes, I know we have on a number line, okay? I understand that. But we're going to graph on the coordinate plane today, okay? So, in your notes, you're going to want to draw a coordinate plane, of course. And now we're going to graph this inequality. Well, the first thing we do is we pretend we have an equal sign. So I'm going to rewrite it off to the side just for a second like this. Now, guys, we didn't cover this in the lesson before on how to graph single variable equations. Equations that have just an x or just a y. Remember the 3 methods you learned were used on equations that had an x and a y, okay? The reason I didn't go over this, and I knew we'd come across, I did not forget. I was just like, they should have learned this in Algebra 1, and plus it's so ridiculously easy. I'm not going to spend a lesson teaching it. We'll just cross that bridge when we get to it, and we're finally to that bridge, so let's cross it, okay? What you do whenever it's a y all by itself, that means you're going to graph a horizontal line, so make note of that. If the equation is an equation that has only y, and the y must be all by itself, so if you had an equation like this, you'd want to divide both sides by 2 to get y all by itself, okay? So if you have only a y in the equation, okay, and the y is all by itself, it's going to be a horizontal line. So y equals 3, you go to the y-axis, you go to positive 3, because that's the number you have here. And you draw a horizontal line that goes through that point, alright? So let's go ahead and draw a horizontal line going through that point. If I can get my pen to work. I think I'm actually holding my pen upside down. It's not going to help. And there we go. Now there's my horizontal line. So I'll put that right there. Okay? Easy enough, isn't it? And now, so step 1's done. Pretend you have an equal sign. I'm going to erase this. Pretend you have an equal sign and graph the line. Be sure to check to see if the line is dotted or solid. Well, do you see how there's an equal sign right here? It's greater than or equal to. Whenever you have that there, it's going to be a solid line. Now, if this had not been here, then you would have put a dotted line like this. Okay? So, check to see if you have a dot or a solid line. By the way, that's one of the most important things that students forget on tests or quizzes, and they lose points for that. Always check to see if your line is dotted or solid. Now think about it. Here's a horizontal line. If you're going down, I mean, just common sense. You think when you're going down, things are getting smaller, and when you're going up, the numbers are getting larger. So notice it says y is greater than 3. Do you see that? Everybody see that? Y is greater than 3. So you're not going to shade down here where it's lower. You're going to shade up here like this. Y is greater than 3. And that's what step 2 says to do. Decide where to shade. If it's a vertical or horizontal line, then it's easy to shade, okay? Now, that's it. We're done. We finished that problem. However, I want to talk to you for a second. I want to bond and become one with the graph. I'm just kidding, but we need to talk about this for a second. So here's what I want to point out to you students. This inequality, y is greater than or equal to 3. What ordered pairs on this graph satisfy this inequality? Well, all of the points that lie in the shaded area. And because we have an equal sign here, the points on the dotted line, the points on the solid line are also part of the shaded area. So, any point up here is a solution to this inequality. Any point down here is not. Okay? So you've graphed the linear equalities. You've actually solved them in a way. Okay? Because you've actually got a picture of what the answer is to this inequality. And here's the picture of it right here. Let's try another one. Okay, step 1, pretend that the inequality symbol is an equal sign. So I'm going to pretend I have an equal sign. And I'm going to graph the line. Now, this is one of these single variable inequalities. Again, they're so easy. I have only an x, no y. I mean, do you see a y anywhere? Of course not. And x is all by itself. When that happens, that means you will always have a vertical line. So the last problem, when you had y all by itself, well, I erased it already, sorry, but you had a horizontal line. Here you'll have a vertical line. So I go to the x-axis. And I go to -2. Here's the x-axis. I go to -2, and I draw a vertical line through -2. There, I've done it, but I did make a mistake. It's my fault. I forgot to check to see if the line is dotted or solid. Do you see how there's not an equal sign right here? Hopefully some of you caught that. So because of that, I know that it should be dotted. So I'm just going to go like this with a white pen real quick. And I guess with you, if you make a mistake like this, you could use your eraser and make it a dotted line. But don't forget forget to check, guys. As you can tell, I just did it. It's so easy to do. Okay, so there's my dotted vertical line. You really should put arrows on the end of those. I did not set a good example in the last one. You really should. Now, so we did all of step one, piece of cake. Now decide where to shape, if it's vertical or horizontal. It is easy. X is less than -2. Well, think about if you go to the right, that's greater than. If you go to the left, that's less than. So easy. So X is less than -2. So we're going to shade over here. That's really simple, guys. So not only did you graph this inequality, you basically solved it too. You solved it because you're giving me a picture of the answer. Every ordered pair that satisfies this, every ordered pair that's a solution to this inequality, lies in this shaded area. Now, any points that lie on this dotted line, would they be part of the solution? No, because there's no equal sign here. Thus, this linear boundary, and by the way, I do call these boundaries. Quite often they are boundaries, okay? This linear boundary is dotted. Thus, it is not part of the solution. This here was solid. The points on this line were part of the solution. So this ordered pair right here, 2, 3, right here, was part of the solution. This ordered pair right here, which would be what? -2, 4. -2, 4. That point would not be part of your solution because it lies on a dotted line. Alright? Let this sink in, guys. You gotta know how to do this. Let's get the two difficult ones now. Here we go. Let's try one now with two variables, okay? The steps are still the same. So here we go. Pretend that the inequality symbol is an equal sign. Okay, no problem, I can do that. Let's extend this real quick and make it a little larger. There we go. And let's pretend we have an equal sign just for a second, okay? There we go. Now, you could use the table of values method, double intercept method, slope intercept method whenever it's an x, and then y, the number over here. Double intercept's pretty easy, guys. I'm going to very quickly put a 0 in for y. Oh, let's pause here. What are you doing, Mr. Earhart? I'm graphing the line. Pretend you have an equal sign and graph the line using any of your three methods. I've chosen to use the double intercept method. It's my choice. So where the y is, I'm going to put a 0. -x plus 0 is -x. If -x equals 5, then x equals -5. So there, you found the x-intercept. Go to the x-axis and put a point at -5. Now let's find the y-intercept by putting 0 in for x. -0 plus y is y. Y equals 5. So there is my y-intercept. So just like that, students, I've got the points I need to graph the line. Now, be sure to check to see if the line is dotted or solid. Well, there's no equal sign here, so it is going to be dotted. So here we go. As you draw your line, make sure that you make sure the line is dotted, which means any points that lie on this line, this dotted line, are not part of your solution. Okay, now, some students say, oh, Mr. Earhart, this is so easy. It's less than, so we're going to shade below. You cannot make that assumption. If someone's taught you that, that is incorrect. Okay? And I can prove that to you. If I have time today, I'll do that. I'll show you. That is not how you know how to shade. Look, if it's a horizontal line, look at the symbol and you'll know where to shade. If it's a vertical line, look at the symbol and you'll know where to shade. If it's a if it's a slanted line, you must test a point to see where to shade. I'm telling you, you must do that. So you pick any point that's up here or any point down here. It doesn't matter, students, okay? A lot of students like to use 0, 0 or positive numbers like 2, 2, 1, 1. That's up to you. But you'd better listen to me carefully. Never choose a point that lies on the line. Do not do that. That will not work, okay? Choose a point that lies obviously above or below the line. No, I'm choosing 0, 0, because my, that's so easy to use. That's a great point to test, okay? 0, 0 is such a nice, convenient point to test. Now, you can't always use it because sometimes that point will fall in the line. But we're going to test 0, 0. Now, take good notes, listen to me. So I come over here, and my x value is 0. My y value is 0. So I'm going to put in 0 for x and 0 for y. Notice I'm using my inequality, not an equal sign here. Now let's see if we get out a true or false statement. Negative 0 plus 0 is 0. 0 is less than 5. Now, is that a true or a false statement? Think of a number line. Is 0 less than 5? Well, that's true. So if that's true, that means this point gives you a what type of statement? True statement. So if this point is true, that means that point should be part of your solution. So if this point is part of your solution, then you shade where that point is. And that's it. That easy. That easy. Now you're thinking, Mr. Earhart, maybe you're wrong. You told us you could not look at this arrow and notice shade below, but yet we shaded below. Okay, let me make one change in this problem, okay? Pretend the original problem was this. Let's see. Negative x plus y. Okay, students, I'm back. I paused the video so I can get a really good example. I wanted to make one up so we can go right through this. I'm not going to use this. I'm going to use a different example. All I have to do is give you one example where it doesn't work, and then you'll see you can't always trust it. What if I have negative x, negative y is less than 5, okay? Now, real quick, watch this. If I put a 0 in for, I'm putting, let's see, negative x, negative y, and a negative 5 here. I think that's the example I had. I think this is right. Okay, so if I were to graph this, put a 0 in for y, my x-intercept would be positive 5. Just trust me, it would be. Put a 0 in for x, your y-intercept would be positive 5. Then you draw your line. Well, when you go to test 0, 0, you're going to get out 0 is less than negative 5. Well, that's not true. Here's 0, here's negative 5. 0 is greater than negative 5, so you would shade above the line. So there's one example there where the arrow's pointing this way, but yet I shaded above the line. Okay, so anyways, you must test a point to know where to shade when the line is what? Slanted. If it's vertical, you do not need to test a point. If it's horizontal, you do not need to test a point. But if it's slanted, you test a point and then shade, okay? Alright, moving on to one more. Alright, please copy this in your notes. We're going to graph this inequality, and while you're getting this ready, let's go back to this. So every single answer that satisfied this inequality lies in this shaded area down here. Any points that fall on the dotted line do not satisfy this inequality. They are not part of the solution. Alright, here we go. Now, step one, if I'm going too fast, just pause the video. Step one, we're going to rewrite this inequality with an equal sign. We're going to pretend there's an equal sign. Alright, so there we go. Now, I'm going to graph this line. Obviously, I have an x and a y, so I'm not going to have a vertical or horizontal line. I'm going to have a slanted line. So, I can use one of my three methods. Well, y is all by itself, so why not use the slope-intercept method really quick? Remember how to do that? When y is all by itself, the constant term is your y-intercept, so b equals 5. The x coefficient is your slope, negative 2, and we're going to put it over 1 so that we have a fraction. So I go to my y-axis at 5, 1, 2, 3, 4, 5. And then, now remember, when you have a negative slope, you can put the negative sign in the top or the bottom. Just don't put it in both. Don't put a negative sign there and put a negative sign there. Okay, don't do that. So I'm going to leave mine up top, I guess, because I feel like it. So my rise number is negative 2. My run number is 1. So my rise is negative 2. Don't go up, go down. 1, 2. My run number is a positive 1, so go over 1. So I went down 2 and over 1. Now, is my line going to be slanted? excuse me, is my line going to be solid or dotted? Well, there's an equal sign here, so it's going to be solid. And so here we go. Do the best I can to draw this without having a straight edge. And that'll be good enough. So there we go. There's my slanted line. Now, we've done step 1, totally done, we're good. Step 2 says you've got a shade. It's not vertical, it's not horizontal, so it's not going to be easy. We're going to have to test a point. Well, thankfully, 0, 0 does not lie on the line, so I can test that point. So let's see what we get. Here's a y, I'm going to put a 0. Here's an x, I'm going to put a 0. And let's simplify and see what we get, okay? Negative 2 times 0 is 0. 0 plus 5 is 5. I'm getting out 0 is greater than 5. Well, students, that's false. 0 is not greater than 5. So this point right here is false. So if this point's false, then I definitely don't want to shade down here where this point is. I want to shade where that point is not. So the proper area to shade is up here. So every single ordered pair that falls in this shaded region and all of the points that fall on this line, because it's a solid line, all of those points are solutions to this inequality, and you've also basically solved it. You've given me a picture of the solution, plus you've graphed it also. Okay, so there we go, guys. Students, not too difficult. If you'll follow the steps and test your point when you're supposed to, and be careful with your little mistakes, you should be fine with this assignment. If you have any questions, don't hesitate to call or email.